Hello, my name is Juan Camacho. Today I'm going to present the poster entitled Water Chemistry and Stable Isotopes Reveal Complex Subsurface and Surface Water Interactions in a Highly Altered Urban Stream in North Central Texas. My hypothesis is that urban streams, catchments, are very complex hydrological networks where water sources interact. During rainfall events, flash flooding can enhance solid transport via direct runoff from permeable and impermeable surfaces. As runoff integrates diverse sources, it can lead to significant alterations in the water quality of the stream. By identifying the transport mechanisms and the use of water-stable isotopes, we can reveal the flow paths, solid sources, and travel times, providing insights for a sustainable watershed management. The research questions are: what are the primary sources contributing to surface runoff in the stream? What are the primary solid transport mechanisms in the stream during rainfall events? What are the predominant urban water sources involved in stream generation during extreme precipitation events? The study site is Rush Creek. Rush Creek is located in the city of Arlington. It covers an area of around 126 square kilometers. It's mainly composed by residential use, around 49%. The rest is divided in infrastructure, transportation, parking lots, parks, and vacant parcels. The methodology: we sample event-based and weekly samples for precipitation and stream flow samples. We also use the sample for water stable isotopes analysis for the vegetation mixing. In addition to these, we do water quality measurements to study the concentration and discharge relationships with the discharge measurements we do bi-weekly and during the events. And finally, we get high frequency imagery using the gauge cam system in the stream. The background is that there are three common types of pattern: dilution, chemostasis, and mobilization. The dilution means that concentration will decrease as discharge increases. Chemostasis will remain, the concentration will remain constant, and in mobilization, the concentration will increase as the discharge increases. We also plot the concentrations with the discharge using the hysteresis loops. We have three types: clockwise, anti-clockwise, and 8. Clockwise, the concentration peaks first, so you have a peak in the concentration before the peak in the discharge. In the anti-clockwise, the flow in discharge peak first, and in the 8 value you have like different peaks in the concentration from different contributions. For the water-stable isotopes, we plot the local meteoric water line, and then we see that O18 ranges between 1.8 to -16. And looking at the graph from DXS, we can see that there are different sources in the stream, like composing the water in the stream. For that, we selected an event during April 2024. In this event, we have 45% of base flow, 23% precipitation, 18% of soils, and 9% of irrigation. Here you can see the plot of all the events. There were 16 events of precipitation that revealed that the main contribution was from precipitation. For the water quality, this was an event in 2025. At the beginning of the year, we identified two types of mobilization mechanisms: mobilization for phosphates, TOC, total organic carbon, tannins, and dissolved iron, and chemostasis for nitrates. Then in terms of hysteresis loops, for this storm, clockwise hysteresis loop was the predominant pattern. The only one that had a different shape was turbidity, with exhibit an H-shape loop. Here you can see the base flow, how it's in the rising limb, during the peak flow, and in the recession limb. And finally, as conclusions, Rush Creek's flashy response shows a direct influence from precipitation events, while mixing analysis revealed water inputs from urban sources such as shallow soils and irrigation using tap water as a proxy. In terms of concentration and discharge patterns, the hysteresis loop suggests that sediments mobilize early in the rising stage and decrease during baseflow recession. The A-shaped type mechanisms might indicate if sediment resuspension delayed from upstream subbases and storage saturation or drainage system effects. As a future research, We aim to combine water quality data with stream imagery to develop machine learning models able to predict water quality parameters based on the color of the images. We aim to develop tracer aid models to understand the hydrological response of Rush Creek. Thank you.